So the problem is the expression yn is equal to xn plus a into xn minus 1. That is, forgetting of all previous things, with what context this equation is, nothing is required. There is an input array of xn which ends starting from 0 onwards, that is fed as an input to a computer program, and that is supposed to generate computer program, or even you can say a manual calculator, means you can write on paper, or a computer program, and that is expected to generate y0, y1, y2 and so on. So the general expression is xn is yn is equal to xn plus a yn minus 1. That is to be converted into an expression for yn, but what we don't want is, we don't want yn minus 1, yn minus 2, etc. It must be only in terms of xn, xn minus 1, xn minus 2 and so forth. So that is to be formed apart. So how do we move ahead? What we write the problem statement? It's just like you do in the question paper. When you don't know anything, you write down the problem statement first so that you feel that I am doing something. So the way in which we should flow is very simple. We don't want something, so try to replace that. The problem, see, we are not thinking of any big miracle. We are going in a straightforward manner. What is the problem statement? This expression will convert into an expression which does not include previous output terms, right? In the given expression, there is something which you don't want. So obviously, what we don't want needs to be replaced. So what is yn minus 1, by the way? You can put n minus 1 equal to m, then ym would be xm plus ym minus 1, then again put m equal to n minus 1. If you are very classical, then you can do that, but I think by common sense everybody understands yn minus 1 by applying same logic is y something is equal to x something plus y something minus 1. So yn minus 1 is xn minus 1 plus, oh, we made a mistake here, only given expression is ay. So plus a into y n minus 2, y minus 2, right? So that you put there, so yn becomes xn plus a into xn minus 1 plus a y n minus 2. So that is equal to xn plus a xn minus 1 plus a square, and what you can put there? Y minus 2 is xn minus 2 plus a y n minus 3. So that you can again expand. I think by just observation you can get the formula. Plus a xn minus 1 plus a square xn minus 2 plus a cube and here what we did, here this we expanded this, a square we did, and for y minus 2 we replaced. So a square a cube and y minus 3 is xn minus 3 plus a y n minus 4. So what can be the general expression? I think by simple logic, xn plus a xn minus 1 plus a square xn minus 2 plus a cube xn minus 3, and again a raised to 4, and same thing will follow. So plus a I can put a is a raised to 1, right? And 1, this is xn, means 1 xn, right? Means
A raised to 0.
a raised to 0. I think this is very obvious and straightforward. No rocket science here. So a raised to 0 xn. So can I write n as n minus 0?
Yes.
Right? So in the summation formula, what can you write? Whatever is here, and that is 0. Then that is 1, that is 2, that is 3. So you can replace it by variable k. So summation k equal to 0 to infinity
A raised to k
a raised to k
x n minus k.
of n minus a raised to k x of n minus k. Is it right? So both these two are equivalent expressions. What is the yn is equal to x. Yn is summation of k equal to 0 to infinity a raised to k x of n minus k, and yn is equal to x of n plus a of y of n minus 1. Right. So they are different on different things. These are simpler. This does not involve any kind of output. So this is non-iterative. It involves output, so it is iterative. This is terms are infinite. Here terms are. So either you get a non-iterative infinite term expression, or iterative finite term expression. Iterative finite term expression. Is it right? For computing, what would be simpler? For computation, finite term, because as we grow, as n moves, even though computer is having very big things, but sampling rate is also very fast. So if sampling rate is 1 microsecond, in 1 second there will be 10 to 6 samples. So each time you have to go for this long procedure of many term addition. But if you use finite term, it becomes simple. So either a finite term iterative expression, or an infinite term non-iterative function. Right? So at least now so this is very simple, and it doesn't require a prerequisite. xn. Now this a raised to k, this is called as a raised to k. This a raised to k is a coefficient. For each previous term the coefficient is different. So in this case it is a raised to k. So in general we can have yn is equal to k is equal to 0 to infinity hk x of n minus k. So this tells an output is a weighted sum of current and all previous inputs. Output is what you are talking, what you are doing? Look here. Output is weighted sum of current and all previous inputs. Sometimes, so this is general expression, and this all instead of all, so an expression which is, or an expression which makes output to be a weighted sum, or the same is called in standard method linear combination of current and all previous inputs. The same can be converted into an expression of current input, maybe few past inputs, and at least one past output. So when one past output comes, it takes into consideration current and few previous inputs and past to past output. That past to past takes care of prior to that. So in turn, this infinite term expression, this iteration makes it finite term. So this is one. Now sometimes, so this is expression but computed using this. Sometimes suppose that what you are today is because of what you received yesterday, day before yesterday, maybe right from the birth or maybe in the previous. So what you are today is because of these multiple things. But what happens is that you are having some finite memories. You recollect everything at the past but not much things. So like that, the coefficients HK are not so bigger as K grows. Those are there but not so big, not so large in values comparatively. So in that case, sometimes this expression can be an approximation of few previous terms. Just like say what I remember only for last year, previous I think I forget. So this m previous terms, or if total m terms are there, then m minus 1 previous term. So hk x of n minus. So this is finite previous terms. So in general there are only two types. This is alternate expression of this form. So current output is a combination of current and previous inputs, whether previous few or previous all. If it is previous few, it is called as FIR, that we will discuss that finite impulse response system, otherwise it is called as IIR, infinite impulse response system. So all those classical terms we will elaborate later. See now, what is made available to you? 8-week sessions of Professor Gadre and my 14 lectures for the previous year. So there should not be any issue of what is there for the T1 and what is not there, right? So what somebody asked me, that Moodle and all these things are guidelines. We are not in what we can say primary school, so that don't go for that. Only thing is that whatever is not taught will not be asked. So the content in Professor Gadre's week, even though it is 8 weeks, so we have only 5 weeks, but 8 weeks, 1 week, the contents are hardly of 1.5 hours. So those 8-week lectures of Professor Gadre, and yesterday I have put my 14 lectures. So those you should finish, and it is I presume that you are watching all these things, either here or later on, or in both ways. He may be watching both. So that I think that test T1, T2 should be, it's a requirement and not our, what we can say, ultimate target of learning. So these are the two terms. Now these are the two formats in which our current output is a linear combination of current and previous inputs. Previous may be few or all. Now I write one more expression. One most important thing is that this must start from 0. K can't be negative. If K is negative, then what will happen? If K is -1, K -1 means some constant and x of n plus 1. That is futuristic. That is called as, you might have gone, whether if you have gone through videos, so non-causal system it may be. Sometimes in image processing that is permissible, because in image processing is spatial domain. This and previous means on the left hand side and next means on the right hand side. So in image processing that is allowed, but in normal case, in real-time system that is not allowed. So right now let us say that k is starting from 0 onwards and not minus. So once this is clear, we have what? Yn is equal to convert this expression into same thing. Convert this into an expression which does not include y terms. So you can convert. We will put a pause on video. After some time we will elaborate.